Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show today, bringing you again another fascinating guest involved in some fascinating technologies focused on creating a better tomorrow for humanity. Today, we have the honor of being joined by Dr. Egbert Edelbroek, who is currently the Chief Executive Officer and founder of a company called SpaceBorn United, which is a research and mission design company which is focused on researching the optimal conditions for human reproduction in space, with a focus on novel assisted reproductive technologies. Dr. Edelbroek is passionate about accelerating space life science research, ultimately helping humanity become a so-called multi-planetary species. His interest in this area and in space exploration in general accelerated back in around 2010, where he actually became a sperm donor and learned all about the field of assisted reproductive technology. And this ultimately inspired him to explore options to look at how one could potentially re-engineer some of the existing technologies like IVF, which we have nowadays for application in space. Dr. Edelbroek received his Ph.D. Studying the field of courage development in organizations at Radboud University. He also has a master's in neuro-linguistic programming and coaching, as well as a master's in organizational sciences from Nijmegen and Tilburg University, respectively. He enjoys innovating and exploring various boundaries by connecting different domains and experts in these domains that normally may be separated, but ultimately helps bring them together to get things done and find new possibilities. So we're honored to have him with us today. Dr. Egbert Edelbroek, welcome to our show, and thanks for joining us.
Thank you, Ira, for having me and for your warm introduction. It's a pleasure to be here.
It's great to having you. I would like Egbert to start off like we typically do by handing you the floor for a little bit, just to talk a little bit more about you. If you can introduce a little bit more than I went into there in the bio about your background, and a little bit about, take us back to 2010, how everything moved from sperm donor to sort of your interest in this fascinating domain of turning us into a multi-planetary species.
Yeah, sure. Be happy to. So as you mentioned, I like innovating different concepts, bringing together different fields of expertise, and that led me to organizational science and becoming an entrepreneur myself, and quickly after also to realize my dream to become more of a scientist. I did my Ph.D. research, and meanwhile, indeed, I also decided to become a sperm donor for an IVF clinic. And my interest in space exploration, which I always had, triggered a question to me that this specific IVF technology, how that could be re-engineered to also be applied in space, because obviously humanity needs to learn how to reproduce in space if we want to become multi-planetary. So actually that's where it started, and that's a little bit more about my background and how I got to the idea. And I mean, this is just yeah, I'm an entrepreneur. Sometimes I have ideas. Usually the ideas turn out to be already existing or not feasible or something like this. But fortunately, this idea seemed to be really relevant, and it seemed to attract a lot of people.
Working along those lines, as you were just saying, there's a quote on your website: if humanity wants to become a multi-planetary species, we also need to learn how to reproduce in space. And it's one thing to build the rockets and the space stations and everything else, but we have to think about these other issues. And when we get, a couple hundred miles up that way, things change a lot, and it is a very, let's just say, difficult, complex place to be. Radiation, tremendous variations in temperature, G-forces, on and on and on. Talk a little bit about some of this, because, I think, in general, we have a Hollywood perspective of everything that happens, once you get up there. Talk a little bit about some of just the physical issues that, putting aside reproductive time being, just in general, that impact human biology that you have to take into account when looking at some of the sort of these strategies.
Yes, of course. And you mentioned some of the most important challenges if human life should thrive in space, or at least stay for some time in space. Indeed, radiation is one of the two big issues. Gravity being different, that's the other big issue. And the good news is that there's hundreds or perhaps even thousands of scientists already working on addressing the radiation issues from all different perspectives. They're progressing well, so that's being taken care of, so to speak. But the different gravity and the effects of the gravity, the level of gravity on Mars, for example. NASA is aiming to go to Mars with SpaceX and ESA and many others, and with that different gravity level, how that will impact the human body or even developing embryos, that is unknown, and that's where we add a lot of scientific value. So there's a lot of data gaps in terms of the partial gravity domain, so to speak. We know a lot about normal gravity, Earth-like gravity. We know quite a lot about microgravity, which is inside which astronauts experience inside the International Space Station when in orbit.
Yep.
But we hardly know anything about the effects of partial gravity, while that information will be crucial to prepare for human settlements on Mars, for example. And with our experiments, we add this data to fill those data gaps. And we let's not go into too much detail yet, but just to confirm the concerns that you mentioned, space is a hazardous environment. We have to address a lot of things.
Exactly. And we'll get into some of what you're doing today, some of sort of the projected mid and longer term parts of the research program, but talk just a little bit about your setting up of the company. I mean, one can go to the website. You have a very amazing team with all sorts of different disciplines. Talk a little bit about, just because one of the things that I mentioned in the bio that you're very fond of and specializes is bringing these people together that may not work together. I mean, you don't have people that are experts in vitro fertilization talking to people that are experts in low gravity physics or whatever it may be. Talk a little bit about the company, setting it up, and a little bit about this team, because it is very impressive. And if you can talk through sort of what it's been like recruiting and getting some of these people on board to think about these different types of projects, that'd be a great thing to hear about.
Yeah, sure. So the company, I mean, first we understood, okay, the reproduction challenge is difficult to address for other institutions, for especially for the big agencies. So that gave us a reason to exist.
Yeah.
I mean, anyone would expect, okay, reproduction in space, NASA is working on this, or ESA, or I don't know, SpaceX. But it's very challenging for them, because they have to work, well, at least the agencies, they have to work with taxpayer money, and taxpayers, well, they don't have the time to understand very complex challenges like space life science challenges, especially reproductive challenges. So that gives us SpaceBorn United a reason to exist and a reason that it attracts all these experts. And we are super proud of all these renowned experts that are reaching out and showing interest and helping us. We even have Dr. Sheila Ali on board now in the advisory board. She's worked for NASA, the biology programs, for 10 years, and her expertise is actually IVF in space. So that's like 100% match with what we're aiming for the next couple of years.
Absolutely.
We have Dr. Alexander Leyendecker. He did his Ph.D. research on sexology and reproduction in space, supervised by NASA. So we have experts with solid backgrounds. We have we have from different regions in the world all kinds of astrobiologists, but of course also people that can help us with designing the missions. So the mission architecture experts and space system engineering experts that know how a satellite works and how we can adapt a satellite and how we can arrange biosamples to not only go into space, but also return to the surface of Earth to examine them after having been in space. And we're very happy that there are research partners and universities reaching out to help us. And we are very happy always to support students and graduation projects that also help our projects. So, and the focus of our company, that wasn't clear, of course, in the beginning. So we had to, we were struggling to define our focus. What is really, what does the sector need? What does humanity need? So we eventually learned that our focus should obviously be on as you mentioned, exploring the options for and the conditions for reproduction in space and for different stages of reproduction. Reproduction is not one event; it consists of different stages. So you have conception stage, you have the embryo development, the childbirth, and all substages. So we learned that our focus is three things. The first is exploring the conditions for different stages of reproduction in space. The second is that we translate the outcomes of this into a missions program. So we are also a mission design company, as you mentioned. So that results in a missions program, each mission focusing on a different stage of reproduction. And the third thing is we develop biomedical equipment that is required for those missions. So, for example, we are re-engineering IVF technology as a life support system to enable IVF in space and the conception and embryo development. So that's a little bit more about the company in a nutshell.
Excellent. Excellent. And yeah, you touched on a very interesting point for, for those that may have, endeavored to partner with organizations like NASA or ESA, International Space Station and so forth to do experiments. I think they may, the public might think, okay, this is, here's my stuff, just throw it on the next SpaceX that's going up there and we'll do some experiments. But there's really a very complex set of, as you were saying, planning that has to go into before you get the experiment done, just getting things planned out down here to get on, one of these missions and so forth. Quite recently, you announced a memorandum of agreement with a Malaysian company that is involved in, a private, I think they're involved in manufacturing different re-entry capsules and so forth, Independence X Aerospace, and on this mission, you will be starting out, really with, looking at rodent embryos in artificial gravity and sort of taking to the very first steps, doing the fertilization, then bringing things sort of back down to look at the biology and so forth. Talk a little bit about sort of what's involved with this project, but at the same point, the planning of it, because again, it's not just put it on the rocket ship and get something back. There's a lot that really goes into even something at this level of creating an embryo.
Exactly, and you mentioned indeed that this is about working with rodent embryos first. You have there. It's ethically it's super delicate to eventually enable human conception in space and later on the other stages. So the ethical committees, they will not approve of such things if you do not have a solid step-by-step a program in which you first have a tech demonstration, you validate that your space IVF technology is working, and then you can start working with rodent gametes, reproductive cells, to turn them into embryos and have them develop for some time before you can even move to work with human gametes, human reproduction cells. So and indeed, this Malaysian company is one of the key companies that will be helping with getting biosamples, getting embryos that have developed in space, getting them back to Earth to study them, to see what this partial gravity did with them. Does this gravity level that we expose them to, does that enable healthy embryo development? So this Malaysian company is indeed producing re-entry capsules. And inside that capsule, we will have our IVF in space device carrying the reproductive cells, and they will grow into embryos. And after 5 days, we need to pause the embryos in their development, because after 5 days, in this way, embryos need the natural womb to grow further. So we need to pause them in their development, and we do that by cryogenically freezing them.
Okay.
So in the same way that IVF clinics do things like this every day. And also this freezing will protect the embryos for all the vibrations and the G-forces that happen during the re-entry. It's quite violent, the re-entry process back to Earth. And this Malaysian company is very flexible, very passionate to work with us. And you asked about planning. So pretty soon, in early next year, actually, it's not decided if it's going to be March or April, but one of the two, we will have our prototype, our IVF in space prototype, on board a rocket that goes to space. So that's a big milestone for us. It's a test flight, so the device will stay on board the rocket. It will not be in a re-entry device yet, and the rocket will be recovered with the payload, our payload in it, and that will be one of our technology demonstrations. And then about a year later, we expect to be able to do a similar mission, but then an orbital mission where we will have a biosample in space, embryos developing for 5 to 6 days, and then returning with this Malaysian company's recovery device, and then with rodent embryos. So that's the planning for the next year and a half, more or less.
Yeah, it's exciting, and clearly the first steps on something quite amazing. As you obviously, and once again, I'll put the links in the bio of the show to the organization, and people can obviously go through and see some of sort of the longer term visions of what a lot of this looks like. But one of the things I did notice I think it was a presentation you gave recently, actually. Last year I had Jasmine Cook on from discussing the perinatal life support program in the EU, artificial womb work, and working with Dr. Oy at I'm forgetting the university, but we also just recently had Dr. Jacob Hanna on from the Weizmann Institute discussing his synthetic embryo work. Now, clearly, these are okay. Maybe if the artificial insemination work is maybe stage one. Maybe these come a little later, but obviously you need to start thinking about these now. And it's nice to see that you are liaising and discussing some of these tools. Artificial womb technology also has some. I'm sitting here in Philadelphia, and we have some of that going on down the street here at the Children's Hospital Philadelphia. As you think about sort of the these next steps, clearly there other technologies that are being developed on Earth terrestrially beyond the air, the IVF. Talk a little bit about some of what you're doing sort of on the let's say the technology scouting front, because there are other people that are doing tools that, needless to say, you will need, whether it's on the space station, Moon, Mars, as part of this chain. Talk a little bit about what you're looking at there, and please bring in sort of the artificial womb folks as well, if you would.
Yeah, sure. But we're following those developments very closely. We're in contact with the group that is working on the artificial womb in the Netherlands, with the Eindhoven University of Technology.
Right, Eindhoven. Sorry.
Group. Professor Oei, indeed.
Right.
I've been in contact with him and his
Excellent.
colleagues. So we're following their work closely. The focus of their research is, and their hardware development, let's not forget that, is to solve the problem of premature babies and the lungs being exposed. Well, the difficulty, the challenges for the lungs of the baby if they're really premature. So they're not developing the artificial womb for purposes of space exploration.
Right.
That is the reason that why we are monitoring it. They're aware of this, but that technology will eventually help humanity to also have options to address the other stages of reproduction. Similar to the work of the team of Jacob Hanna from the Israel Institute of Science, the Weizmann Institute. He's also very much aware of that. We're following his spectacular results of his team, enabling mouse gestation in an artificial womb for even 11 days, and they're aiming to and expecting to extend that to the full embryo development period for mice. So that gives us a perspective that we might be able to also extend our 5 or 6 day missions to an 11-day mission or even longer. So that's very interesting for us. I mean, there will be a lot of people asking, but why not do it in a natural way? Why not, well, send a couple into space, let them have intercourse, let the natural conception occur, but that would be ethically and medically a huge problem. We don't want to do that we don't want to expose the mother and the baby to the risks of space for such a long time. It will be a big waste of resources. It will be super complex and expensive. So a lot of reasons not to involve adult people yet. So we can ethically, in a more acceptable way, do this in a small volume, in like a shoebox volume, in an unmanned biosatellite. And later on also with artificial wombs. I hope they can also get really small. We'll have to follow that. But that's the reason why we are using all these artificial technologies, because it would ethically and medically be super irresponsible to do this with humans.
Sure.
And animals. So with artificial wombs, with artificial reproductive technologies, we can do it in a much more efficient and acceptable way.
Thinking about the natural way for, we could segue over to this and then we'll come back. You were a couple of months ago, you were on this Concordia University panel with Dr. Shauna Pandya, who I had on the show last year. They mentioned Simon Dubé. And the title was Bringing Sex to the Final Frontier, a panel discussion on space sexology. And, you talk about all sort of the ethical ramifications, so forth, of research, but in general, you can't ignore the fact that as we become that space, that multi-planetary species, we're going to want to have sex on the moon and on Mars and wherever we go. And you point out some really, I mean, you talked about sort of different issues on this panel in terms of intimacy and so forth in space. In general, there's a lot of sort of physiological stuff as well. I mean, if you just think about gravity for a moment and blood flow, not to mention, how a lot of those difficult things happening up there may affect all the different neurohormones, right? I mean, we're more than just blood flow. And how, obviously Hollywood believes that we're just going to be floating in the air having sex and everything will be okay. But you got to think about these other issues as well. Talk a little bit about what happened on this panel and a little bit of what you guys were discussing.
Yeah, so it's funny. I'm being asked several times to join those panels, while basically SpaceBorn United is now focusing on, well, let's say taking sex out of the equation,
right?
Doing it all in an artificial way. So it's and I have to say, so sex and sexology in space is not our expertise, but being on those panels, having a lot of discussions with those experts, we learn a little bit. And of course, well, there's a strong relationship between sex and reproduction, and that's why we are usually combined in these panels. But there are some basic obstacles for achieving sex in space, as you mentioned. But the reason why sexology is an issue is not just for reproductive purposes, but also for well-being.
Right.
It's better for the health of people, of astronauts, or even space tourists, if they stay a long time in space, that there can be intimacy and that they can have intercourse, and it has a lot of health benefits, mentally, physically. So it's a valid topic to study. How will that happen? As long as you are careful with causing conception. So sex in space is a good idea for the next, I don't know, 50 years, as long as we don't use it for reproduction. We're not ready for natural sex, natural reproduction in space yet.
Sure.
We're actually working with Professor Cullen from Radboud University on an article about the ethical and medical problems that would occur if you would try that. Because the upcoming space tourism and space hotels, there will be a magnet for all kinds of couples trying to be in the history books to create the first naturally conceived baby in space, etc. Maybe even upcoming space nations will encourage their citizens to try that or whatever. That's irresponsible, and we're explaining that in this article.
Got it.
But the panelists, the colleagues in the panel, sexologists, they're especially focusing on the how question. How can we achieve? How can we facilitate having kind of normal intercourse in space? And the why. So and the answer to the why is not so much we need to reproduce, but we want astronauts to stay healthy, and that then enabling intercourse and intimacy is very helpful.
Yep. What speaking of
oh, sorry, by the way, the same people, I think it was Shauna Pandia, myself, but also Alexander Leyendecker and Simon Dubé.
Yep.
It's usually they're asking the four of us.
Yep.
And
I noticed that.
we will be on the panel in South by Southwest in March to talk about sex and reproduction in space.
Nice. As you work on these protocols and you think through all the issues. Obviously, you've been mentioning a lot about the ethics, and the one thing that obviously comes to mind now when we talk about things like ectogenesis and in the case of sort of the synthetic embryo work, there's a limit to what you can do down here today in terms of how many weeks you can grow an embryo and all that. What are sort of where legally and so forth, where does sort of the terrestrial rules for some of this stuff end up there? I mean, when you think about sort of I don't know exactly how to phrase this. Sort of like, where does the international I mean, I know the United Nations has sort of a group
Space
dedicated to
Treaty.
some of that, but at the same time, thinking through the other issues, like if my wife gives birth to a child on Mars at some point, who are they? What are they a citizen of? And all these sort of things that I guess at one point you're going to have to start thinking about. But you talk a little bit about that whole that area of sort of the legal component of this, and some of the things you start debating
Yeah,
or
it's a really interesting area that is also part of the challenges that we have to address or relate to. And indeed, we have been one of the first things we were asking ourselves is, okay, what will be in the passport of a baby born in space? What is there on place of birth?
yeah.
Um, Apart from the legal implications, and we have this topic checked by space law experts, and they said there's no answer to that question yet.
Mm-hmm.
There is similar situations that I mean, there's people born on airplanes.
Yep.
They don't like this, but it has happened, and it could still happen. And legally, there's different regions that have different laws about it. Usually, it is the country where you board a plane. As long as you're still on that plane, you're legally still in the country where you left. But there are some differences. But those laws might be used as a reference to decide how we will do this in space. So, which is the country where you boarded a spacecraft or something?
Mm-hmm.
But where does it end? There's a lot going on in the domain of space law. There's these very old space treaties recognized by a lot of countries, but there's a lot of work to be done.
Mm-hmm.
Actually, I don't know all the exact answers. We just know that for the next decade or so, we just have to comply with Earth regulations,
yep.
with ethical committees applying Earth-like laws for innovating things like IVF or embryo development.
Makes sense.
But it's very interesting, and there's organizations. There is an NGO with the ambition to become the first recognized space nation. Some people might have heard about them. Asgardia.
Mm-hmm, mm-hmm.
I'm also involved with them, and their work is also focusing on enabling reproduction in space, but also they're doing a lot of work on legislation. So they have a constitution, and they're working on a framework that could be applied for when people start living in space.
Yep.
And everything that's involved with living and reproduction and everything. So that's a very good exercise, I think, because we're going to need it. We're moving into space gradually.
Absolutely.
So we need to know, okay, we have different laws on Earth, but what happens on the moon? Which law do we apply? So there's a lot going on there.
Absolutely. Absolutely. Egbert, as you have this first mission, samples going up, doing experiments coming down, you're going to be learning a lot of stuff. Clearly, some of these learnings, whether they're about G-forces or temperature or the whole sort of cryo component of this, have other applications. And I'm just wondering, maybe it's too early to know, but if you think through some of this, we took a hot topic for us on many shows is sort of so-called dual use. Is there something that the military creates that's useful for us in the private sector, vice versa, and all that? Any interesting sort of insights on, potential dual use applications for some of these tools? I mean, that are going to be, if they're great for doing X, Y, and Z in the space station or on the surface of Mars, they're going to be good for something here as well. Say a few words about dual use.
Legitimate question, obviously, and Yes, the experts that we work with, they have a lot of expectations about potential dual uses, especially regarding improving IVF treatment on Earth. We are innovating IVF technology, where it's being done in an unmanned biosatellite, so everything is done remotely controlled.
Mm-hmm.
And we're making it all very small, so that will probably lead to improvements for IVF treatments on Earth, but bigger. I mean, there's millions of couples depending on those treatments, so that's really valuable. But some other elements are the epigenetic factors, the gene expression factors. And we're exposing developing embryos to the environment, to a different environment in terms of gravity, in terms of radiation. And that is expected to cause changes in gene expression, even transgenerational epigenetic factors. One of the expectations, potential options is that the children that will be developed and born in space, their offspring just might result in better astronauts that are better suited for partial gravity and radiation exposure. So that is, very exciting for us, that potential perspective. But we're looking at things like this. We're very busy, we're understaffed. So we are very busy with the plans that for the short term.
Sure.
These dual uses seem to make sense in the further future. So we're making sure to look into that a lot.
Yeah. That whole area of resilience, and the telomere case with Scott Kelly, I think it was, on the space station, and does hanging out in zero gravity extend your life potentially, and all that, I think is fascinating. And I think there's going to be a lot more there in the short term that improving sort of human resilience down here. I see a lot of different tributaries stemming from that early work. So no, that's exciting. Egbert, one other thing I wanted to ask you about, obviously we've been spending a lot of time, you're going to be doing rodent experiments. Obviously the grand vision here is humans, but what about things like pets, other organisms? Because clearly, whether they're cats, dogs, we're a bird family, that they're a part of our lives as well. Talk a little bit about some of what you're thinking about and looking for in terms of the non-human component of your technology for Mars and beyond.
Yeah, that's important. I mean, the first steps of our experiments, we use rodents because of the ethical committees and the ethical steps we need to follow, and we want to follow that path. But eventually, if humanity wants to have a permanent, independent settlement to start with on Mars, for example, we will also need biodiversity. We will need plants and trees and animals, and there's a few challenges there, not just the terraforming itself, that's a huge challenge, obviously, but also knowing which animals will thrive and which will not. I mean, the gravity is really different. It's only 39% of the gravity that humans and animals are used to in the plants. So the interesting thing is that the astrobiologists in our team, our research partners, they suspect that our research platform, our technology, our IVF in space technology, can also be applied to other mammalian species than just humans. So, for example, if the outcome of our research would be that the Mars gravity level is not enough for safe human embryo development, for that it might need, for example, 64% and not 39%, so a lot more than there is now, then we could design countermeasures. We can even think of things like rotating bedroom areas. So we have to spend the night on Mars with some extra Gs to compensate for the lower gravity during the day. That could be a solution, or or at least for pregnant women, perhaps. But you can tell that to a human being, but you cannot tell that to, well, a squirrel or other animals. So we need to study which animals, and then probably select those animals that can thrive in that Mars gravity environment. And our platform, our assisted reproductive technology and space device, can help study and select those animals. So this is an early, well, let's say an assumption, and there's a lot of homework to do, but it's very exciting that we might also be able to help study and define the biodiversity that is possible beyond Earth.
Outstanding, really outstanding. Egbert, I want to ask you about one other, as we're talking about all this, and this is clearly, as I mentioned at the beginning, this is not, these are not little steps. I mean, this is very ambitious frontier style work. And I noticed, and I forgot to mention from your bio that, another terrestrial initiative that you're involved in, you were the CEO and founder of something called the LEF Academy, which basically is focused on coaching and teaching professionals to, in essence, be more innovative, to, sort of how we go about making more Egbert Edelbrooks to think innovatively and sort of get out of a comfort zone and do more ambitious style work. Talk just a little bit about LEF Academy and sort of how we, particularly as a society, help push more frontier thinking and people to get away from sort of the standard stuff that most people are comfortable with.
Yeah, I'd love to. Let me start with explaining what LEF stands for. That's Dutch for courage.
Yep.
So it's all about courage development, what I did my Ph.D. research about. So we help individuals in organizations or in their private lives to expand their comfort zones. There's a lot of psychological self-cheat interwoven in our DNA into our cognition. And if you can recognize that and work your way around it, those are all these different steps that can help you become more courageous and have a richer life. And that's I think the connection between, or maybe some personal added value to SpaceBorn United. I mean, I like to expand the comfort zone of people, of organizations, of groups, or even humanity. I mean, if we will be multi-planetary, talking about expanding the human comfort zone. But that's indeed, I put it on hold, this company, because SpaceBorn United is asking all of my attention.
Sure.
There's some small things that I still do. I turned my very boring Ph.D. dissertation, which is super scientific. Well, I think a standard dissertation is somewhat boring to the larger audience. So what sometimes happens, and which I also did, is translate it into a more consumable book. And I wouldn't be the CEO of let's say Courage Academy if I didn't arrange a real book launch. So in the first test flight happening in March, April, that book is also joining the test flights. It's going into space. It's a real book launch.
Nice.
But that's the background of LEF, or let's say Courage Academy.
Excellent. Excellent. Yeah, I just wanted to reconnect that back because I neglected to mention it, and I thought, clearly this is a very courageous and ambitious program. So I wanted to link that too. Egbert, you mentioned another, an upcoming sort of sexology related panel you're going to be on. Anything else happening? I mean, obviously you have the launch coming up in March, but other things that we should know about before we wrap up the show, other conferences that you're going to be presenting at, other panels, places that we can listen to you, potentially meet you, and anything else that I might have missed, please.
I'm not sure if I can reveal this, but now I have to explain what I mean. There just might be a documentary upcoming with the same people that will be on the panel in March 14, South by Southwest. And that,
Excellent.
yeah, I think I should not mention more than that. But
That's fine. Don't get in trouble.
yeah, we're very proud that we're approached, and it's in preparation, and there needs to be some deals need to be finalized, but it's very likely that they will proceed.
Nice. Excellent.
And other panels, yeah, there's every so many weeks. I would recommend people, of course, to and invite people to follow us on LinkedIn.
Yep.
Our website is pretty obsolete, to be very honest. We are, as I mentioned, a little bit understaffed, so we have to prioritize, and updating the website is not our key priority. We do like to update on LinkedIn.
Yeah. Okay.
So the SpaceBorn United LinkedIn page will, of course, also tell people when there's panels that could be interesting for people.
Awesome. Awesome. Yeah, we will put, as I mentioned, we'll put that in the that link in the bio to the show. But yeah, no, really, fascinating set of programs. Wishing obviously you the best with the launch coming up in early 2023, and we will continue to follow, and hopefully we can do a follow-up episode next year after the first set of experiments. For everybody, again, listening to this particular episode of the show across the various podcast networks or watching us on the YouTube channel, again, you've been listening to Dr. Egbert Edelbroek, CEO, founder, SpaceBorn United, doing really amazing work to ultimately make us a multi-planetary species. Egbert, I want to thank you for taking the time out of your schedule to come talk to us for a little while about the things that you're up to. Obviously, thank you for doing them. And as we like to say on our show, thanks for helping to create a better tomorrow via what you're doing. Really fascinating work.
My pleasure. I would be happy to join you next year sometime.
It'll be great to see you then. Be well.